All right, so we are going to create a flip chart on the characteristics of functions. So hopefully you have already created your flip chart. Basically what I did was I took 4 sheets of paper, staggered them on the bottom, and then folded them over. So on the top cover is labeled as the characteristics of function. Let me scoot this out a little bit so you can see it all. So I think in this video, you're going to need to play the video, but pause it so that you can fill in what information you need on the flip chart. Okay, so please don't hesitate to pause the video if you need the extra time. All right, so characteristics of functions is the cover, and then here are your tabs for each page. So you might want to start at the bottom one and then go up, but hopefully you can see that for each of these, I have a different topic on there. So again, you might need to pause the video so that you can get this completed on your flip chart. All right, first up is domain and range. Now, I already have my flip chart completed, so I'm going to use a handy dandy piece of paper to cover up so it doesn't feel too overwhelming. All right, first part. The domain is talking about the x values of a function. So when whenever we talk about functions, we're talking about x values and y values, and we have this situation where the x values are not going to be repeated. Okay, well, this is just listing what the x values are. So the x values of a function, the way we're going to use or write it is called interval notation. So this is an interval right here. So we write the smallest number, comma, the largest number. All right, so we always go small to large. So if I were to assign homework problems and I told you I wanted you to do numbers 7 through 3, you would think I was crazy. So we always do smallest to largest. All right, now this is the smallest x value of my function. This is the largest x value of my function. This comma is basically representing everything in between, meaning not only the integers between 3 and 7, but also all of the fractions and decimals between 3 and 7. So it literally means everything in between there. Now, we're going to talk more about interval notation, but these are brackets, which tells me that it starts at 3, including 3, and it runs through 7, including 7. So kind of how we do a solid line or a dotted line when we shade an inequality. This is showing you that this is included in the domain. So we use brackets. All right, again, if you need to pause the video so you can get this written in, please do. All right, so now I'm going to go over and talk about the range. Well, the range is the same thing, except the range is talking about the y values. So I just made this up. The smallest y is -9. The largest y is 2. The comma represents that it's everything in between. So everything from -9 to 2, including -9 and 2. So these brackets are telling me that -9 and +2 are both parts of the range. So the domain refers to the x value and the range refers to the y value. All right, on your next page, we are going to talk about intercepts. Now, we've talked about these earlier this year. We looked at how you can graph with the x and y intercept. So this should not be new material here. So the x-intercept is the point where the function crosses the x-axis. This is always going to be something, 0. So if it crosses the x-axis, that means that y is 0. So if you write it as an ordered pair, it would be whatever your x-intercept is, comma 0. All right, the y-intercept is kind of just like the opposite, really. So the y-intercept is the point where the function crosses the y-axis. And we know from Math 8 and linear functions that the y-intercept is, we use the variable b for the y-intercept. So that one can be used, so you could say 0b would be the ordered pair for the y-intercept. All right, next up, we're going to talk about maximum or minimum points. All right, we'll start with maximum points. I think this makes sense. A maximum point is going to be the highest point of a function. All right, if the function goes on forever, then there isn't a highest point. So the maximum point is going to be where the function is its highest y value. So I made this little sketch here. So this is a function, and I just made up the numbers. But this point right here would be the maximum. That's the highest point on this red curve. So that would be considered the maximum. All right, now the minimum is, again, kind of the opposite. The minimum is going to be the lowest point of a function. So I drew this kind of like a W right over here. And there are 2 points that are the lowest points. So what I was trying to show here was that you can have more than one highest point or lowest point, but they're going to be at the same height. So both of these are the lowest point because they're both go down to -2. If one of them went a little lower than the other, then there's only one minimum point. So the minimum point is going to be the lowest point on your graph. And then I put this one right here just to demonstrate that if you had something like a line that's going to continue on forever, there is no highest point. And if we look down this way, there is no lowest point. So it is possible to not have a minimum or maximum point. All right, that takes care of minimum and maximum. Next up is increasing and decreasing. So I'm on the increasing or decreasing page. All right. Increasing or decreasing describes the direction the function is going from left to right. So just like when we do interval notation, we always write the smallest number first. When we do increasing or decreasing, we're always going to go from left to right. So it's kind of the same idea. All right, we're going to use interval notation again, and we'll work on that a little more in class. But just to figure out what I mean by increasing and decreasing. So I drew this wave here. So if I trace from left to right, that's where we're getting the increasing and decreasing from. So starting from the left, this is increasing until I get to this line right here. And here I kind of cross over a boundary and I start decreasing until I get to about here, and then I cross over this boundary, and then I start increasing again. And then this arrow would indicate that it's just going to continue. So this part right here is increasing. This part right in here is decreasing, and then from the right on is back to increasing. All right. Next up is positive. So the positive part of a graph, so I'm on the positive page in my flip chart. Positive is talking about when the function is above the x-axis. So basically, I want to know when are the y values positive. So when am I above water? When am I above sea level? I want to know when on the x-axis are the y values positive. So we're also going to be writing this in interval notation. So I made a little sketch here. Again, I did a curve just to show you because it does kind of bounce back and forth. So really what I'm trying to do is, when is this curve above the x-axis? Well, it's above the x-axis over here and between there and there. So that's where we'll get the interval notation in. So positive is talking about when are my y values positive. So if we cover up, y values are positive north of the x-axis, if you want to say that. So anytime my graph goes above the x-axis, it's considered positive. All right, the next page in our flip chart is negative. So I think you can probably take a guess at what's happening here. When we talk about the negative part of the graph, we're describing the x values when it's below the x-axis. So basically we're looking for when is y negative. So the function is negative when the y values are negative. So here's a sketch of this one. So again, I did a kind of wave here just to show you because it's going to oscillate back and forth a little bit. So if I want where the graph is negative, I want to know when is the function below the x-axis this time. So when the function goes below the x-axis, it's between here and here, and from there on. So I'm looking for when the y values are negative. All right, last one is end behavior. And end behavior is really just telling us where is the graph going? Where is the function going at the ends of the function, okay? So we're looking at the arrows. So if the arrows are at the end of a function, we're looking like, where is that going? Is that increasing forever? Is it decreasing forever? Where is it going? So the end behavior tells the direction that the function is going to continue to go. All right. Now this is a little more complicated of a sketch, and you'll probably definitely want to pause this and then listen maybe more than once. So to find end behavior, I'm looking at the ends of my function. Here's one end of my function, here's the other end. This side's on the left, this side's on the right. It's that complicated. All right, once I know where that arrow is going, I'm going to use the signs of the quadrant. So in the first quadrant, these points are positive, positive. In the second quadrant, those points are negative, positive. Down here in the third quadrant, these points are negative, negative. And in the fourth quadrant, these points are positive, negative. So the way end behavior looks is we would say, since this arrow is in this quadrant, it's staying in this quadrant forever. So x is just going to keep getting more and more negative, and y is just going to get more and more positive. So this arrow is just going to continue in this quadrant. So the signs of my x's are going to be negative, the y's are going to be positive, and it's just going to go on forever and ever. It's never going to stop, so that's why we use infinity. Over here on this end, this arrow is in the first quadrant, and it's going to stay there forever. So this function is just going to continue in this quadrant, and it's just going to continue to get more and more positive on the x and more positive on the y. So x is approaching infinity, y is approaching infinity, because this is just going to continue to get bigger and bigger and bigger for the x and the y. It's just going to get more and more positive. All right, we'll work on more of this in class. So this was just to get the general notes down and your flip chart created. So what we'll be doing now is we'll be given a graph and we'll name what's the maximum point, what's the minimum point, what's the domain of this, what's the range of this, when is this graph positive, when is this graph negative, what's the end behavior, when is it increasing, when is it decreasing. So we're just looking for these features or characteristics, like it's called, when we take a look at a function.